Good morning. I don't know if it's morning for you guys right now, but it's morning for me. So, good morning. But, solving rational equations, unit 4, day 1. So, we've been working with rationals. Now we're actually going to start solving them. Okay? So, let's just get into it. So, a rational equation is any equation that contains at least one rational expression. So you know what a rational expression is. It's just some fraction pretty much, and it has an equal sign now. Now we have an equal sign. So that's what a rational equation is, okay? So there's the procedures to solving these. You can read them if you want. Keep them there so you can look at them as we go through these, okay? So let's look at example A. So we have x minus 2 over 5 minus x minus 5 over 4 equals negative 2. So the first thing we're going to find is the common denominator. So the least common denominator is 20 in this case, because our only denominators are 5 and 4. 5 and 4 go into 20. So that is our least common denominator. Then we would state restrictions. There is no restrictions on this one because there's no variable in the denominator. Okay? Now, we're going to multiply our common denominator to each part of our equation to get rid of the fractions. So we're multiplying to get rid of these fractions. So I'm going to multiply each individual one by 20. Okay, so I'm clearing the denominator. That's what we're going to call that. We're going to clear the denominator. Now, let's just reduce these. 5 goes into 20 4 times. 4 goes into 20 5 times. That last one stays. So then you're left with 4 times x minus 2 minus 5 times x minus 5 equals 20 times negative 2. You multiply that out, you get 4x minus 8 minus 5x plus 25 equals negative 40. Now we're just going to solve this. We're going to combine like terms. So that's negative x plus 17 equals negative 40. Subtract that 17 over, you get negative x equals negative 57. So x equals positive 57. And then that's your answer for that one. Okay, let's do another example. So example B, we have x minus 2, or x minus 1 over x plus 2 equals x squared plus 2x minus 3 over x plus 2. Our common denominator here is x plus 2. So the restriction for that is x cannot equal negative 2. And that is very important. Remember when you guys kept saying, why are we doing restrictions? This is stupid. We're doing them now because now we have to double check our restrictions when we get our answers. Okay, so our restriction is x cannot equal negative 2. And now I'm going to multiply each part of these by x plus 2 to clear the denominator. So x plus 2 over x plus 2 reduces to 1 or they cancel. X plus 2 over x plus 2 reduces again. So we're left with x minus 1 equals x squared plus 2x minus 3. Now we have a squared term, we have an x term, and we have a constant. So we need to move everything to one side so that we can solve this by factoring. So I'm going to move the x over, add the 1. You get x squared plus x minus 2. If you factor that, that factors to x plus 2, x minus 1, which means x plus 2 equals 0 and x minus 1 equals 0. So x equals negative 2 and x equals positive 1. But if we look back at our restriction, x cannot equal negative 2. So that one does not work. X just equals 1. Okay, that's why we have to write our restrictions. And I want you guys to always write the restrictions right when you find your common denominator. That's when you should deal with your restrictions. Okay? Let's go to this one. So if we look at example A, the common denominator here is x, because we only have one fraction there, and the only denominator there is x. So my restriction is x cannot equal 0, and now I'm going to multiply each thing by x. Even if it's not a fraction, you still have to multiply everything by x, because we have to multiply. We have to do it to everything so we don't change the equation. Okay, those x's cancel. You're left with x squared minus 12 equals x. Let's move that x over. So it's x squared minus x minus 12 equals 0. Factor that. X minus 4, x plus 3. So x equals 4, x equals negative 3. We just double check our restriction. 4 and negative 3 are not 0. So both of those work. And that's your final answer. Okay? We're not doing example B, I guess. Let's go to example number 3. So here we need to find our common denominator. We have x plus 1 and we have x plus 4. So I'm just going to have both of those be my common denominator. So my restrictions here are x cannot equal negative 1, x cannot equal negative 4. And now I'm going to multiply everything by x plus 1 and x plus 4. So in that first one, the x plus 1's cancel. Second one, x plus 4's cancel. Last one, the x plus 4's cancel. And you're left with x times x plus 4 plus x plus 1 times 3 equals x plus 1 and x times x plus 3. You multiply that out, you get x squared plus 4x plus 3x plus 3 on the left side. And you combine like terms, that's x squared plus 7x plus 3. Now on the right side, when you multiply that out, you get x squared plus 3x plus x plus 3. You can do it by distribution, you can do it by using the box, but you can't just multiply the first and the last terms. You guys should know that by now, but you can't do that. Okay, so then that's x squared plus 4x plus 3. And now let's just solve this. So I'm going to move my x squareds over. Those actually cancel, so you're left with 7x plus 3 equals 4x plus 3. Move the 4x over, you get 3x plus 3 equals 3. Move that 3 over, 3x equals 0. So x equals 0. 0 is not negative 1 or negative 4, so that's our answer. Okay? Let's look at example 4. So here, that x squared minus 9 is not factored yet. So we need to start by factoring that. That factors to x plus 3, x minus 3. Okay? So our common denominator here is x plus 3, x minus 3. The restrictions are x cannot equal negative 3 and x cannot equal positive 3. Now I'm going to multiply that to each individual one. Okay? In the first one, everything cancels. X plus 3 and x minus 3 both cancel. Second one, x minus 3's cancel. Third one, x plus 3's cancel. So we're left with 2 plus 5 times x plus 3 equals 3 times x minus 3. Multiply that out. That's 2 plus 5x plus 15 equals 3x minus 9. Then let's just solve this. So 5x plus 17 equals 3x minus 9. Move the 3x over and you get 2x. Minus the 17, you get negative 26. Divide by 2, you get x equals negative 13. Negative 13 is not negative 3 or 3, so that works, and we're good. Okay, you always have to double check those restrictions every single time. Okay, we're going to skip this one. Let's look at this one. When you only have one rational expression on both sides, you can solve these by first stating the restrictions, then cross multiplying. So these ones are the easy ones. These ones you should be excited about. Okay, if we look at example A, 5 is the same thing as 5 over 1. So let's just write that as 5 over 1. Okay, and let's state our restrictions. So 1 minus 2x cannot equal 0. That's negative 2x cannot equal negative 1. If you move that one over, you divide by 2, so x cannot equal positive 1/2. Okay, I just solved the 1 minus 2x for x to get that restriction there. Now, we have fractions on both sides of the equal sign, and we don't have anything being added or subtracted. Okay, so I'm just going to cross multiply these. So I have 1 times x plus 2 equals 5 times 1 minus 2x. So that's x plus 2 equals 5 minus 10x, and then let's just solve this. So move the 10 over, you get 11x. Subtract the 2, you get 3. So 11x equals 3, which means x equals 3/11. And then that does not equal 1/2, so we're good. That's our answer. Okay, you would do example B in the same way. The restriction there would be negative 2 because the x plus 2 cannot equal 0, so x cannot equal negative 2. Cross multiply that, and then you would just solve. Okay? Remember to take the quiz, and I will see you guys after fall break. Okay, bye.